So now we've got our PCBs in and it's going to be time to assemble them. This is the point in the project where it can be really tempting to just try and rush through it just to get it done because we feel like we're so close. However, we need to be careful to make sure that we don't shoot ourselves in the foot at this stage. So first we're going to take our boards and we're going to assemble them according to our layout and our schematic. And then we're going to walk our way through each of the different blocks. But as we do so, we want to make sure that as we're assembling the board that we're using good soldering practices. We want to make sure that we don't have any cold solder joints or any solder bridges, because all those will do is make debugging later that much more annoying and frustrating. So what you will see is that I have already populated my board with all the components, and then I fly wired in my controls. The reason for that is because I'm using board mounted pots, but if I mount them right to the board from the get-go, I won't have access to any of the solder pads that are underneath the pots, which will be useful not only for debugging but also for tweaking any values if we decide we want to swap any components out. And then I'm also going to solder in some temporary wires that are going to allow me to connect my PCB to my test box. And using the test box, we're going to first just see if we get signal to pass all the way through it, because we know that we've got a good schematic. Our board is laid out according to the schematic, so in theory it should just pass everything through. And if it doesn't, then we start tracing our way from the beginning all the way through the end, trying to figure out where things might have gone wrong. If something has gone wrong, then we're going to make some tweaks to our schematic if necessary, into our Gerber files, and we may need to do another revision of the board. So let's go take a look. Okay, so here's our board. You can see that we've got everything set up the way that I mentioned we would. We have our controls fly wired off here. I've got my power, I've got my input and my two outputs. A couple of things to note real quick is that you'll see that these electrolytic capacitors, I determined were going to be in the way of the input jack, so I've kind of moved them off to the side. I soldered them in with plenty of lead so I could bend them around the edge of the board or off to the side. I've also laid down the voltage regulator. But actually, after a little bit of playing around, it's still going to be a little too tight, I think. So I may need to actually relay out the board in such a way that there is either nothing here, or I may need to try and relay out the board so that I'm taking advantage of the space down here that's going to be around the stomp switch. Another thing to note, this header here is my mode jumper. So right now I have it in the mono mode because I only have one channel on my sound card to record. So we'll hear both what would normally be left and right will both be on the left channel. I have this jumper here, which is my delay line 2 source select, set to be my left in. So this is going to be a mono in stereo out. If we were to move this jumper over to here, we could, in theory, run our input right into the right side, and we would then have two separate inputs to our two separate delay lines. So it would be just a standard stereo in, stereo out delay. You can see that it's pretty tight squeeze, everything on the board. There is not a lot of open real estate here. And then this may be a little bit of a boring section because I did a little bit of playing around with this before filming, and I actually found a really big flaw, which has to do with my feedback pot. You'll notice that it's supposed to be a dual gang pot, but I've only got a single gang pot off here. That is because I managed to fry both of my dual gang feedback pots, trying to figure out why I was not getting any sound on my second delay. I was getting sound through the first delay just fine, but the second delay wasn't working. And it turns out, I'll turn this over real quick, it turns out that we didn't have a DC blocking cap off of that second lug of this portion of the feedback control, which is the one that governs how much signal is going to the second delay stage. So what happened was, because that pot got fried, I would get the delay out of the first stage, but it couldn't get through this pot to make it to the second stage. And this is the first time I've ever actually destroyed a potentiometer in any way, shape, or form. But the way that I determined that it was bad was that I actually pulled the pot off, I unsoldered it, and I took resistance readings between lugs 1 and 2, 1 and 3, and 2 and 3, just to see what the resistances were reading. And between 1 and 3, it was reading my normal my normal resistance that I expected, which I think I had a 100K pot, which actually I need to get a 50K pot for what I want, but I had a 100K pot. And so I was measuring 100K there, and when I had the pot fully counterclockwise, I was measuring 100K between 2 and 3, as one would expect. But instead of getting continuity between lugs 2 and 3 here, I was actually seeing like 250 kiloohms or something that was way bigger than the actual value of my pot. So I knew there was something that was off. And after the fact, I opened up the pot, poked around inside, was not able to bring it back to life. So I actually need to order some new pots so that I can put a dual gang one here. For now, I've just got the single gang, so we won't actually be able to hear any feedback, but we will be able to hear the first stage and the second stage. These controls over here are for stage 2. The controls over here are for stage 1. I have it set to independent mode right now, where the time and mix are independent on the two sides, just so that I could exercise all of the controls. So here's just my... So you hear that I've got 2 repeats there. If I were to reduce the time on 1, so you can hear how I've got almost that instantaneous little slap back repeat from the first stage and then a long wait to the second stage. And if I turn my mix down on 1, turn it down a little more maybe. Let's give it just a little more delay time there. So you can hear that I've got plenty going on there. Let's give it full force over to the... So there we go. So unfortunately, what that means is that aside from this feedback pot, everything worked exactly the way we thought. I guess that's not all that unfortunate, but it doesn't make for a very interesting video. So if I were to actually just if I were to just come and play a little bit here, let me bring the guitar over here and we'll just play with this guy a little bit. So I actually like how that is sounding. I feel like most of what we did on the breadboard, bump my mic stand there a little bit. I feel like what we did on the breadboard was sufficient to get the get the tonality that I wanted. So I'm actually not going to go playing around too much with values, but if I were to play with some values, I would probably play with the capacitor that is in the multi-feedback networks just to adjust the cutoff frequency a little bit maybe, or I might take the RC filter that is off of each of the delay stages and maybe pull the cutoff frequency down just a little bit. It's fairly bright, but at the same time a ping pong delay is supposed to be fairly bright. So on the whole, I'm really quite pleased with it. Though I am going to do up a new board layout. I've already fixed the schematic to have that that DC blocking cap in there. So now I just need to figure out exactly how I'm going to change the board layout, because this is a very large board, and for example, right here where the switch is, I can get a jack over that space just fine, but over here I think that like my regulator is going to be too tall. So I'm going to have to see if there is a way that I can kind of push some of the stuff down a little further, maybe extend the board so that it kind of comes off around to the sides of the stomp switch. So I'll just have to play with that in Eagle, but I'll probably just end up showing you guys the finished project, show you some gut shots maybe when I'm all done so that you can see what the final board layout looked like. But I mean that's really all there is to it at this point. We put in a lot of time and effort up front to vet our schematic and to try and create a reasonable layout, and that has really paid off with the with what we've got. The only thing wrong was that I missed a component. So when you get lucky and all the stars align, that's the type of thing that'll happen. A Rev 1.0 board rarely works perfectly. In this case, it didn't work perfectly because I missed that cap, but we'll do a 1.1 board, and yeah, should work great. So we'll see what happens. Well, so there you have it. It's not quite the perfect polished finished thing that we thought we would have. There are a couple of small changes that need to be made. Most specifically, we need to relocate those electrolytic capacitors away from where they are going to interfere with the jack. And we also need to make sure we put in that DC blocking cap on the feedback pot so that I don't fry any more potentiometers and so that the circuit actually works. So what I'm going to have to do is I'm going to have to actually spin another revision of the board and get that made. And when it comes back, what I'll do is I won't do another one of these videos, but once the pedal is all done and it's all boxed up, I'll do a demo video of the finished circuit and maybe have just a little bit of discussion in there about anything else that I changed, if anything, or just any other considerations that there may be. So after filming that last part, I felt it was kind of lame to just leave it there. I decided that rather than push out a video that didn't have everything in it that I wanted, that I would rather wait until I could do the video in its entirety so that we could actually show a working circuit at the end and not just some sort of circuit that kind of got some things hacked into it to sort of make it work. So what I did was I created another revision of the board. I did end up using the space around the stomp switch, and I ended up moving a couple of other things around just to try and make it so that it wasn't as tight of a squeeze in there, because that circuit, doing it all through hole, is a pretty tight squeeze in a 125B. And especially when you throw in the fact that we've got 5 potentiometers, 3 of them being dual gangs and 2 switches. So it's a lot to cram in there. But the new revision of the board came back. It's looking really good. So what we're going to do is I'm going to go ahead and cut over to my workbench, and I'm going to walk you through briefly the changes that I made, and just a couple of points there. All right, so here's what our 1.1 revision of this PCB looks like. You can see that I've got it all assembled now. And I just wanted to point out a few things. The first is you can see that I did end up using the space around the stomp switch, which in this case is a 4PDT. It takes our mono in, gives us a stereo out, and we have the LED connection there. It was just, the real estate around here was just too valuable to not use. You can't really notice it because of all the other ones that are in there, but one of these 1 microfarad capacitors is our DC blocking cap from our feedback pot that we had an issue with the first go around. And then I don't think it's very clearly visible, but underneath the input jack here, I have actually notched out the board a little bit. Because this is a dual gang potentiometer, it's a little bit thicker, and I just wanted to try and minimize any kind of interference between my jacks and the board. You'll notice that my electrolytic capacitors have all gotten crammed in the space between the jacks, but only sort of in between the jacks. And then the output jack is over the top of the sync mode switch, so the independent or synchronized mode toggle switch there. The one thing that I did goof up here a little bit is that the pads for the ground for my input and output jacks are actually underneath the jacks, and the jacks lay right down on top of the board, so there's no way to actually get a wire in there, which is why you see my really ugly hack job of running the output ground over to the input ground and the input ground over to the power ground there. It works. There isn't any noise or anything, but if I were to go back through and do yet another revision of this board, I would probably drop a ground pad somewhere around, you know, here-ish, and probably one somewhere around this time 1 potentiometer. The other thing that you'll notice is that I actually have these resistors across lugs 1 and 3 of both gangs of my time 1 potentiometer. The reason for that is that in order to do the shotgun shell knobs, they had to be press-on knobs, which means I had to have the spline shaft potentiometers, but Tata only had the spline shaft PCB mount dual gang potentiometers in B100K, not B50K. And while 100K is fine for feedback and for mix because they're just voltage dividers, it doesn't work for the time setting on our PT2399s, because if you get too high of a resistance there, then the internal VCO of the PT2399 isn't able to sync enough current to maintain a stable delay, and it doesn't really work at all. So because this is a 100K pot, it's a 47K ohm resistor across each of those, meaning that the maximum resistance is right around 50K, which is what we wanted in the first place. So the maximum time is something on the order of between 600 and 800 milliseconds. I haven't timed it at all. But there we have it. It's a very large layout. It takes up the majority of the inside of our enclosure here, but everything is working really well. There's enough space to pull the jumpers and move them if we need to configure them for different modes. our trimmer here helps us set the brightness of the bypass LED, so if we use a different color, then it doesn't really matter. And there we have it. I have already pre-recorded a stereo demo of this in action, so we're going to go ahead and cut to that now. So there you really have it. Now we have a fully working circuit. We have gone through the entire design process from the beginning to the end. We started with our initial concept. We went through the schematic creation and then our breadboarding so that we could make sure that what we created in a schematic would actually work. We then laid out a PCB that we sent off. We got it back and we learned that sometimes when you're making a PCB, the first one doesn't work quite right. In fact, I find that most of the circuits that I do something stupid and I have to do at least one more revision. Some of my other projects I've had to do many revisions of, and that's just kind of the nature of what we do. We are imperfect human beings. Sometimes we'll make some mistakes. But now we've got our box all working. I'm going to go ahead and do my usual write-up and demo video with it and everything so that you can build one as well if you would like. But more than anything, I hope you took away some useful information about how you can go about taking your ideas for a circuit and turning them into something that is your own, turning it into a real full-fledged circuit. I love overdrives, distortions, boosts just as much as the next guy, but there are only so many tube screamers that someone can build. What I like to see is when people take something and either really expand on the functionality or they really push something in a new direction. And those are the kinds of things that really get me excited. So I hope that you won't be afraid to take the plunge into creating something that may be new or different or that we haven't really seen before. With that, thanks for following along. I will try and do some more videos that kind of go through some of the design or build or debug process, but they're not going to be as in-depth as this series has been. This series, again, was all about showing the entire process, really getting into it, because I didn't find any videos online that really dug into what are the things that you need to take into account, and let's actually do that. So I'm glad to have you along for the ride. If you found any of these videos fun or entertaining or useful, I invite you to go ahead and subscribe or head over to my website to check out some of my other projects. I've got over 20 original projects that have all been designed and released for the DIY community. I do all of this just so that we can all have fun and so that the community can have some projects for things that maybe are not as common out there. Again, thanks for coming along, and we'll see you next time.